4.1 Exponential Functions Day 2. Your learning goals are that you will be able to graph exponential functions and use compound interest formulas. The graphs in this section will be in this form. Where your base will be E now. Remember, E is an irrational number, and it's located on your calculator right above the ln key. So it's going to look like this, e to the x power. So let's graph h of x equals e to the 2x plus 2. And when you're graphing, remember you need 3 x values. I'm going to use the 3 basic ones, -1, 0, and 1. And with these graphs, you need to use your calculator because e is like a number like pi. So if you were to actually type in e to the first power, it would be like 2.71. It would keep going on without repeating, and it never stops. So to type in the first one, you do second ln. You'll do e, and your caret key will pop up. Parentheses, 2 times -1 plus 2. And you should get a decimal. We'll just round it to 2.14. And then you do the same thing with the other values. If you plug in 0, you should get 3. And if you plug in 1, you should get 9.39. And then we're going to graph those values. And let's first identify our asymptote, which is always y equals k. So in this case, y equals 2. And we'll plot the 3 points. And there's your graph. And don't forget, we're going to find the y-intercept, which is 0 and 3. Your domain is always negative infinity to positive infinity. And your range, in this case, will be 2 to infinity, but the 2 is not included. Now, exponents can be used to help us with real-world problems such as interest. And here you will see the formulas for compound interest. And there's 2 types of compound interest. You have when your money is compounded n times per year, you'll use the first formula. And T is the number of years. A is the balance in the account. P is the principal, or that's the money that you actually deposit or invest. R is the rate, and you always put it in decimal form. So if it's being compounded n times per year, and these are your possible values for n. Annually means once a year. Semi-annually is twice a year. Quarterly is 4 times a year. monthly is 12 times a year. Those are the most common that you may see. And this is the formula that you use. Now, if it says compounded continuously, you use what we call PERT. And the p-values are still the same. E, just to let you know, is that e to the x key on your calculator. So you won't plug anything in for E. And of course, R and T are still the same. So example 2, we're going to find the various interests using this information. It says a sum of $10,000 is invested. So that amount, that's your principal. That's P. At an annual rate of 8%. That's R. Find the balance in the account. This is A. That's what you're looking for. After 5 years. And that's T. So A, we're going to find it when the money is being compounded quarterly. So N would be 4. And then B, we're going to find it when your money is being compounded continuously. So that's a different formula. So let's do A first. I'm going to write the formula first. I'm just going to plug everything in. Be careful because that's 10,000. And you always put R over N, its own parentheses. Remember, I'm going to change R to a decimal. 0.08 is the same thing as 8% divided by N. And then your exponent is N times T. So when you put it in your calculator, you're going to put it in just like that with those extra parentheses. And if you do it correctly, you should get $14,859.47. B, compounded continuously is our PERT formula. That's what we call it. I'm going to do the same thing and plug everything in. My principal is still $10,000. E, and your exponent is now R times T. And you're going to put it in your calculator just like this. If you do it correctly, you should get a balance of $14,918.25. So if you see compounded continuously yields a little bit more money.